All right, welcome back to the lunchtime video. So I was able to do one video on Saturday, but Sunday I just had a crazy day. So unfortunately, only one weekend video. Hopefully I can do a lunchtime video and after work video and then one video for each day of the weekend. So a Saturday and a Sunday video. And on those, they don't necessarily have to be exactly an hour. It can be longer than that, just as long as I feel comfortable making them. But I was able to do it Saturday, but unfortunately Sunday was just a kind of a crazy day for me, so just needed to take a break. But we're all good to go right now for the lunchtime video. So let's take a look at where we are in studying for this exam. So I'll share my screen. So last video, I looked into routing loops. I tried to just create one myself based on what I already knew. Unfortunately, I didn't really know enough to do that, or there was some built-in protection into the IGP. So I wasn't able to create that loop, but it might not have been just that I was doing it wrong. It's just that the IGP doesn't allow for that I was using. I was using ISIS and OSPF. So I think though I'm going to be setting this one to rest because just creating a loop in my lab is really not that important and it could damage my lab. So I mean, I know conceptually what a loop is. I guess I could learn about loop 3 alternate routes because they might ask me to configure one of those. But I think we're going to be moving on. The testing date is going to be in September, about the middle or early September. So it's going to be less than 3 months. Today is June 22nd, so July 22nd, August 22nd, so that's 2 months. Yep, it's going to be less than 3 months. So, yep, and then let's say that I can go 2 hours every weekday for 3 months, and let's just say that there's 30 days in each month, so hopefully I'll get an extra day or two out of that. So 30 days per month. And let's say that we've got 3 months, so we've got 90 days times 5 days times 2 hours per each of those 5 days. So that's going to be, so 100 times 5 would be 500. But it'll be minus for each of those 5, there'll be 10 less, so it would be 450 times 2, so it would be 900. So it would be 900 hours I would be devoting to the exam from now until the exam date, assuming I never missed a lunchtime video or an after work video. And the other thing it doesn't account for is these intros like now, where I'm just determining if my rate of study is appropriate or not. So this is not, I would not consider actual studying. So this would not be counting into the 900 hours technically. So okay, well, anyway, hopefully that's enough. I'm just going to mark this complete and then move on to the next topic. Okay, so this next topic is one I've been doing, this whole time. It's really not much extra to say. If you're troubleshooting IGP for IPv4 and IPv6. One thing I find really interesting is that they say OSPF and ISIS for IPv6. Well, ISIS does not use IP, it uses ISO. So I don't know how you can troubleshoot IPv6 for ISIS if it doesn't use IP protocol of any version. Okay, but let's continue going. Yep, all these tags look pretty good. Keep the network security on there too, because we'll be troubleshooting. So troubleshooting is, I think you got a secure network is easy to troubleshoot. So it's related in some way. All right, so everything looks good to go. Let's figure out, let's write out some goals, just because I'm really not sure what more I could do for this. Let's start with help apropos on the lab, as is the way I intend to start all topics from now on. Aha, and we can see that the cron job went through. We're at the login prompt, so we don't got to worry about those issues that were there before, because we set up a cron job, and to do that we had to set it system-wide to the system-wide cron file. Instead of just cron tab-e, that only works for your user account, and then you have to run the cron daemon manually. You have to type cron tab enter and then leave it running. So like in a screen or something, and if it ever stops running, your cron job won't go off. But if you have a cron job that restarts your system, it won't start running again unless you have it part of your boot up programs. So in the lab, system-wide cron job's the way to go. I'm not sure about production. I mean, definitely gotta be more concerned about security in production than in the lab. And not just, and the reason for that is because you don't want your customer traffic to be compromised, but in the lab, you know, things go wrong, I just yank it from the wall, and I'm as secure as I can be. Okay, so let's see here. Okay, so right now we've got OSPF set up. So let's take a look at help apropos. And let's see troubleshoot. So interesting. We do have some things popping up. Let's take a look at this one. So here's some common problems that might occur. Maybe there's a problem for ISIS and OSPF. Never mind. This is troubleshooting, common problems for troubleshooting commit scripts. So these aren't common problems that you might want to enable a commit script for to check for. That would have been really useful, but unfortunately that is not what this is all about. Here we go. So let's look at the ISIS standards, and maybe there's something there that has to do with IPv6. Okay, so let's look at this RFC 5308, because this is routing IPv6 with ISIS. Let's see if there's any special considerations for that. And I'll add that to the notes. Okay, so it looks like there's going to be new reachability TLV. And I know TLV is a field in the IP header, I want to say, but it might stand for something else. Normally it stands for type length value, and it's in the IP header. Let's actually take a look at a Wireshark capture quick and see if we can find TLV. So let's set up the connection here, or let's just start a capture here, and then we'll ping across the wire there, get the traffic. So, oops. Well, even with those issues, maybe there's, nope. But we do have an IP header here in these discover messages. As well as an Ethernet header. So if a type length value header were a part of the IP header or the Ethernet header, it would be in these messages because they include those headers. So it does not really matter what protocol the messages are at layer 4 here, as long as they're encapsulated within IP Internet Protocol version 4 and a Ethernet 2 header. Those fields are something that can be checked. Okay, so I actually don't see that. So let's do a Google search for TLV. Taste of Tel Aviv. What is, there's a lot of Israeli food that have like kind of like kushlabaz or like funny names that let's see here. Here we go. Type length value is what I'm looking for in data communications. I am not at this point looking for traditional Jewish celebratory foods. Within data communication protocols, TLV, type length value, or tag length value, is an encoding scheme used for optional information element, okay, in a certain protocol. The type and length are fixed in size, typically 1 through 4 bytes, and the value field is of variable size. These fields are used as follows. Type, a binary type, often simply alphanumeric, which indicates the kind of field that this part of the message represents. So what are the issues with this? So it might contain original research and it does not cite any resources. Okay, well, this is, I think, well known enough to be a fine. Well, you know what? Maybe it's not. I'm gonna find like maybe a networkinghelp.com, something like that. So let's make sure that the results are relevant to what I'm working on by adding the key networking. Okay, so Stack Overflow might be okay. This might be good. Here we go. So it's looking for more like a plain English explanation. Yeah, I have done research and I know somehow, but it is difficult to understand. So yeah, this is where I am too, because you see TLV being used specifically for ISIS. You see it being used in a lot of different ways. I mean, why OSPF v3 and ISIS took the benefit? Well, let's get the answer here. TLVs allow these protocols to be easily updated to support new protocols like ISIS. For instance, by making use of TLVs, it was easily adapted to support IPv6. And I will be taking a 5-minute break. I will be back shortly. All right, sorry for that. I am back though, so let's continue reading. TLV elements can be placed in any order inside the message body, which facilitates the whole process. In a nutshell, TLV is just a piece of binary code that could be added to a routing protocol, for example, to extend its capabilities. As QQ explained, TLV is like a plugin. If you need any additional extension, you need only implement that plugin, which is TLV data. So I will be putting on my headphones. There's some dog barking outside. Let's talk about ISIS, originally supporting only the connectionless network protocol. So when I say that ISIS doesn't use IP, Internet Protocol, it uses ISO, I'm actually not entirely right. It uses ISO, but that's the family that it's a part of, kind of like IP is part of INET. But the actual protocol is CLNP. However, ISIS was extended for IP routing in RFC 1195 with the registration of TLV128, which contains a set of 12 octet fields to carry IP information. Okay, so I'm pretty satisfied with that. TLV is just kind of a more complicated concept than I was kind of giving it credence for, but it's basically just a feature of a protocol that allows it to be extended, where you can set the type, you can set the length, and then you can set the value. So being able to adjust the length, being able to adjust the type, that really kind of gives it more it makes it more adaptable, makes it better long term, gives it more flexibility is the word I was looking for. So yeah, I'm just curious, like, because oh, I can close this now, but here, yeah, IGP for IPv4 and IPv6. So, and the other thing I find really interesting here is they say OSPF. They don't say OSPF version 3, because OSPF version 2 is not compatible with IPv6. So it's interesting that they would not specify version 3. It's almost as, you know, maybe they just expect you to know that, and they don't want to give you the answer that way. Or it's just kind of interesting title. So let's, oops, so I closed that. So let's bring it back up. So, okay, so I think it was, Well, I can always go to my history. There you go. And I will keep this in my notes as well as the other one. And now let's just skim the RFCs. I really don't see the point in giving this a lot of time. No matter where I get to at the end of this video, I think we're going to move on, because in lots of the other videos we have spent a lot of time setting up IPv6, setting up ISIS, setting up OSPF version 3. In fact, you can see on router 1, show configuration, possibly set, no more. IPv6 is currently set up and ready to go. And I've got OSPF 3. I don't have ISIS set up, but yeah, it's deactivated. Okay. All right, so I think we're pretty much good to go. We just need a few more things. Yeah, so we just need to skim through these, and then I think that'll be enough. So let's see here. Oh, and these were updated. This RFC was updated, but it has not been obsoleted. So we're good to go. Oh, this one has, though. This is just the updates. Okay, so definition of differentiated services field in the IPv4 and IPv6 headers. Probably see one of those. So let's look at IPv4 header. So right here, here's an IPv4 header. Yep, differentiated services field. We're gonna have to learn about that in more detail later during the QoS section. That's what that is primarily used for. Yeah, so if we go to the definition here, well, I think we need to jump over, because this is just the extension to it. So we need to, oops. But anyways, it's usually used for bit marking, policing, that sort of thing in QoS. All right, and this is just domain-wide prefix distribution with 2-level ISIS. So that's an extension. I don't think that's going to be relevant. And cryptographic authentication, we looked at that in previous videos. And in the previous video, we learned that you've got to authenticate twice. You can't just apply authentication to all areas. You have to, to all levels. If you have a level 2 adjacency, you've got to authenticate that, and your configuration won't automatically authenticate level 1 adjacencies as well. It requires different configuration. Because the same configuration is just applied to level 1. You've got to apply it to all the levels you want it to be in effect for. Okay, so let's just do IPv6. Oh, we got nothing. Okay, so I think this is the one to go. Yeah, I'm not really sure what this one is about. I think it's yeah, it's for dual routing. So oh, and it looks like the table of contents isn't even working on this one. So this I might want to just not look at. Yeah, I think I'll just remove this one from the notes. Doesn't even have a table of contents. It's pretty old, so let's just worry about this one. ISIS is an extendable intra-domain routing protocol. Each router in the routing domain issues a link state protocol data unit, LSP, that contains information pertaining to that router. The LSP contains typed variable length data, often referred to as TLVs, type length values. We extend the protocol with two new TLVs to carry information required to perform IPv6 routing. In RFC 1195, a method is described to route both OSI and IPv4. We utilize the same method with some minor changes to allow for IPv6. To do so, we must define two new TLVs, namely IPv6 reachability and IPv6 interface address with a new IPv6 protocol identifier. In our new TLVs, we utilize the extended metrics and up/down semantics of RFC 5305. All right, so here's the IPv6 reachability TLVs that they'll need to add. Yeah, I really don't see anything else I can do for this besides just, read an RFC, one of the running themes of this channel, concepts, not commands. So, I could just go type all the commands in again, but I've already done that a few times, and I really, obviously, am a little bit not all the way there with some of the concepts. So let's continue reading the RFC. IPv6 reachability TLV. The IPv6 reachability TLV is TLV type 236. RFC 1195 defines two reachability TLVs, IP internal reachability information and IP external reachability information. We provide the equivalent IPv6 data with the IPv6 reachability TLV and an external bit. The IPv6 reachability TLV describes network reachability through the specification of a routing prefix, metric information, a bit to indicate if the prefix is being advertised down from a higher level, a bit to indicate if the prefix is being distributed from another routing protocol, and optionally the existence of sub-TLVs to allow for later extension. This data is represented by the following structure. The above IPv6 reachability TLV may appear any number of times, including none, within an LSP. Link local prefixes must not be advertised using this TLV. As is described in RFC 5305, the up/down bit shall be set to 0 when a prefix is first injected into ISIS. If a prefix is advertised from a higher level to a lower level, e.g. level 2 to level 1, the bit shall be set to 1, indicating that the prefix has traveled down the hierarchy. Prefixes that have the up/down bit set to 1 may only be advertised down the hierarchy to lower levels. If the prefix was distributed into ISIS from another routing protocol, the external bit shall be set to 1. This information is useful when distributing prefixes from ISIS to other protocols. If the sub-TLV bit is set to 0, then the octets of sub-TLVs are not present. Otherwise, the bit is 1 and the octet following the prefix will contain the length of the sub-TLV portion of the structure. The prefix is packed in the data structure. That is only the required number of octets of prefix are present. This number can be captured from the prefix length octet as follows. Prefix octets equals integer of prefix length plus 7 divided by 8. Just as, and this divided by 8 probably to get it to, to get it to octets. Okay, so just as in RFC 5305, if a prefix is advertised with a metric larger than max v6 path metric, this prefix must not be considered during the normal shortest path first computation. This will allow advertisement of a prefix for purposes other than building the normal IPv6 routing table. If sub TLVs are present, they have the same form as normal TLVs as shown below. Length indicates how many octets of value are present and can be 0. Here's what we need to know. IPv6 interface address TLV. The IPv6 interface address TLV is TLV type 232. The TLV 232 maps directly to IP interface address TLV in RFC 1195. We necessarily modify the contents to the 0 through 15, 16-octet IPv6 interface addresses instead of 0 through 63 4-octet IPv6 interface addresses. We further restrict the semantics of this TLV depending on where it is advertised. For hello PDUs, the interface address TLV must contain only the link local IPv6 addresses assigned to the interface that is sending the hello. For LSPs, the interface address TLVs must contain only the non-link local IPv6 addresses assigned to the IS, so intermediate system. IPv6 NLPID, the value of the IPv6 network layer protocol ID and NLPID is 142, as with RFC 1195 and IPv4. I've got some things here. Way. IPv4. If the IS intermediate system supports IPv6 routing using ISIS, it must advertise this in the NLPID TLV by adding the IPv6 NLPID. Operation, we utilize the same changes to RFC 1195 as made in RFC 5305 for the processing of prefix information. These changes are both related to the SPF calculation. Since the metric space has been extended, we need to redefine the max path metric from the original specification in RFC 1195. This new value is the same as in RFC 5305. I guess I don't remember what 5305 is. Oh, I see. Extensions. If during the SPF, a path metric would exceed max v6 path metric, it shall be considered to be max v6 path metric. I don't need these anymore. No more barking dogs. The order of preference between paths for a given prefix must be modified to consider the up/down bit. The new order of preference is as follows, from best to worst. Number 1, level 1 up prefix. Number 2, level 2 up prefix. Number 3, level 2 down prefix. Number 4, level 1 down prefix. If multiple paths have the same best preference, then selection occurs based on metric. Any remaining multiple paths should be considered for equal cost multipath routing if the router supports this. Otherwise, the router can select any one of the multiple paths. IANA considerations. IANA has updated the ISIS code point registry so that TLV codes 232 and 236 refer to this RFC. IANA has also created the following new code point registry for sub-TLVs of TLV236. The range of values for type is 0 through 255. Allocations within the registry require documentation of the use and requires approval by the designated expert assigned by the IESG. All code points are currently unassigned. This document raises no new security considerations. So there's security considerations covered in these RFCs, which I think are just interesting. Oh, and I'm done reading the RFC anyway, so there's more to explore. So, oh, here's IP. Oh, okay, this is the one I just read. So, and here's security considerations, which are just setting up adjacency authentication. All right. Okay, so that took a lot less time than I thought it would. I guess as one final thing, let's set up ISIS for IPv6 and just make sure everything works, and I can ping from Docker guest 1 to Docker guest 2. So I'll just try to do that as quickly as I possibly can because I've only got like 10 minutes left, and I'm going to be needing to go very quickly during the test. Even though it's a 6-hour exam, people often report that they barely have enough time or they actually run out of time. Okay. And I know for sure in the multiple choice tests, time management is very important. Oh my God. Okay, so yeah, I want ISIS, and then I want. Okay, so I'm not sure if I can have. Well, let me just enable ISIS first on all of the switches and disable OSPF. Okay. Okay, so this should be good to go. Oh, we're also going to need the most important one, the one with the NET on it. Network entity title. It's going to be LO0. Okay, so let's do that for all of the routers. All right, so, oh, actually didn't have that deactivated already. Let's just deactivate the configuration for OSPF version 3. And hopefully the family SO, yep, so everything's good to go on there still. Okay. All right, and I'm just curious here, if I do a configure private, is there a way I can deactivate like IPv4 or something like that. No, I was wondering if there was extra options available for deactivate where you could just deactivate what they consider to be typical configuration for some particular kind of setup. I mean, that'd be really nice because on the test I could see what is considered to be typical configuration for something like an IGP if I could just do deactivate IGP, but that appears not to be included in the OS. Of course, you can always write out your own script, do stuff like that. Lots of options in Juniper. Kind of the first to the game when it comes to network automation. So let's deactivate OSPF though and only use ISAS. Okay, so ISAS looks good. Let's get rid of this redistribute. Probably have one of those policies on router 2 as well. Yep. But it looks like it's not applied anywhere on router 2. Okay, so we should be good to go on router 3. So let's configure router 4. All right, so router 4. Oh, it looks like we've only got ISS. We don't have any OSPF. So let's do a show protocols. Oops, how about show routing table? Or just show routes, yep, and then I'll just look at them all. So, yep, you can see we've got both IPv4 and IPv6 all populating due to those. And you can see we are learning them through ISIS, even though if I were to go to any one link, and I will do that. So this link is currently capturing, I believe. I thought there was a link capturing. Nope, no links are capturing. But let's capture this link here. Okay, and then on router 1, let's restart the ISIS process. Well, I mean, we'll see the hellos. Yeah, we'll just see the hellos there. But let's explode the network just so we get more interesting things on the Wireshark Capture. Okay, so we cleared off all the adjacencies, so they'll be reforming pretty quick. So right now they're in state new, they'll be in state up once they are reformed. So yep, that goes to new, to initializing, and then to up. At least from what I can see there might be more steps like OSPF neighborships that don't show up often because they're so fast. But it looks like there's this interesting situation where there are 3 that are stuck in new for some reason. So one of, yep, okay, so they just didn't receive the hello message from the other side yet. I wonder if there's, let's go to edit protocols, ISIS, set interface, GE. Okay, never mind. So I remembered back to the videos for exam 961, where I did a whole series on BGP. So this series, I'm probably going to do BGP as one of the last topics. Next topic I'm going to do is VPNs. I just remembered when BGP forms a neighborship, you have the option to set one router to be the passive router when it comes to forming a neighborship, because otherwise they'll both attempt to form it, but the one with the, I think it's the higher IP, will, the one with the lower IP actually will say, oops, well, you have a higher IP, so why don't you be the person who forms this relationship? Here's a FINAC, bye-bye, you can do all the work, and then you'll see the port that is opened on the IP with the high, the device with the higher IP that's used as an identifier is ephemeral, because they're the one who is initiating the connection, so it'll be to port 179 on the device with the lower IP. So I thought maybe there was something like that with IGPs, but then I remembered it that BGP is a whole different ballgame from IGP. So if you were to make a interface passive, you would say, don't run this, don't send any hellos, anything like that down this port, but do include the subnet that the port is configured with in your updates to the out from the other neighborships. So it's completely different from BGP in that regard, in what the neighborships, how the neighborships are formed, what the neighborships do. Just there's a huge, I mean, BGP is an EGP, ISAS, OSPF are IGPs, so it's kind of no wonder there's such a large difference. All right, so let's, okay, so yep, here's just all the hellos, so let's just keep this running as I'm going through. But yeah, you can see, so here we've got our IP addresses, we've got our IPv6 addresses, we've got a type and a length, so this is like a TLV field, here's the value. So, yep, these all have type length. So it looks like type length values are like just modules you can add on to the packet, kind of a bit willy-nilly. As long as it has the type of length, you can have any value you want. As long as I think the value matches the length. But yeah, I think this length is octets, because you can see 1, 2, 3, 4, 5, 6 octets. Here we've got a length 2. We can see the value here, 1, 2. Here's its 4, and yep, with classic 4 octets. We know all IPv4 addresses have 4 octets. And then 16, yep. So yep, it just lines up to the number of octets. Okay, so yeah, I think this was good enough to see. We're looking through the traffic. We're seeing that they're all TLV messages. We're seeing that IPv6 is included. In a previous video, we saw what happened when you didn't use the correct area, when you didn't use the correct NET, when you had incorrect IP addresses. So I think we got a good stopping point for this topic, because it's just wrapped up in all of the other topics. So I'm going to mark it done. And then the last topic we'll have is routing policy. And then at the request of a commenter, I will be moving on. I will be taking things a bit out of order, which is good, because my whole series I did on BGP for 961, I think is really good. So I really don't, I think, need to do this next. I'll be moving on to VPNs and I'll probably be doing let's see here. I think I'll be doing layer 2 VPNs first, so that there's EVPN in there, and then layer 3 VPNs next. Commenter did want me to do NVPNs, which I thought for a minute were not on the, well, I thought they were on the exam as multicast VPNs, but I actually don't see them on the, oh, well, maybe under multicast. Yeah, so NG MVPN. Okay, yeah, so the commenter wanted me to do NG to MVPN. I'm not sure exactly what that is, but I because of course I'm studying for this exam and trying to learn it myself. That's the whole point of this video series. But I do see that MVPN is on the test under the name NG MVPN. So I mean, I can pick and choose. I'll just do that next. I mean, yeah. So I think the next video will be on finishing up this IGP's topic, and then after that I'll take some things out of order. So thanks for watching, and I'll see you in the next video.